Let's consider some other things about ions versus their parent atoms. On the left, we have a diagram of a sodium atom. It has 11 protons in the nucleus and 11 electrons. Its electron configuration is 1s2, 2s2, 2p6, 3s1. So there's one valence electron. At the core of sodium is the electron configuration 1s2, 2s2, 2p6, which is the same as the noble gas neon. Hence, when sodium loses its valence electron to form an ion, the sodium ion has the same electron configuration as neon. When you compare the size of the sodium ion with the sodium atom, the sodium ion is smaller. Why is that? Both have 11 protons in the nucleus, so both are exerting a strong attractive force on their outermost electrons. The reason that the Na plus ion is smaller is it has fewer electrons, so those electrons repel each other, but if there are fewer of them, they don't repel as strongly as the 11 electrons that you have in the neutral atom. So the cation is smaller because there is a lower electron-electron repulsion. And in fact, it will always be true that a cation is smaller than a parent atom because a cation has fewer electrons and hence a lower electron-electron repulsion. The opposite is true for anions versus their parent atoms. A chlorine atom has an electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. When chlorine gains one electron, it reaches the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, which is the same as argon. Now, a chlorine atom and a chloride ion both have 17 protons in the nucleus, so the attractive force between the nucleus and the outermost electrons is the same. However, the anion has one more electron, and so there is greater electron-electron repulsion in the anion. Hence, anions are always larger than their parent atoms. This table shows some actual numbers. Look here. A lithium ion is more than twice as small as a lithium atom. On the other hand, a fluoride ion is almost twice as big as a fluorine atom. If you compare any cation with its parent atom, you will see that it is smaller. Look at the anions. A chloride ion that has gained an electron has an ionic radius of 0.181 nanometers, and the chlorine atom has an atomic radius of 0.099 nanometers. The atom is smaller than the ion. This is true for all of these anions. Anions are always larger than their parents. Now, an ionic bond is a bulk material that forms in a crystal lattice. Here we've shown sodium ions as the small pink spheres, chloride ions as the larger green spheres. And sodium chloride actually forms a cubic lattice with sodium ions and chloride ions at opposite corners of the cube. Here's a smaller subunit. When you expand it in every direction, you end up with the larger cube.